Okay, I've been cleaning and fixing up my RomeroUK variant. It has 9 coil positions on a lower stator plate. That's this one, and an upper stator plate, also 9 coil positions. And a rotor of 8, all facing same polarity magnets. Has skateboard bearings. And I'm have a plate in between the magnet above and the magnet below, a thin plate in between, and they pinch themselves together. So it's a very strong rotor. I have these timing magnets out here on the rim, but I'm not going to use them. Instead, I'm going to have a small timing wheel up here, and you can adjust the timing by moving this. And here's the Hall effect right here. And there's a little locking screw here. It's made of Teflon tape container. So the way I'm going to do this is for every coil there's going to be a full wave bridge rectifier right here, DC into a cap. And each one has a cap and a full wave bridge rectifier. Every coil on the bottom stator and every coil on the top stator. This is a little different than what RomeroUK did, but so I'm going to rectify each coil, except for this coil and this coil are motor coils, and they are a little bit closer to the rotor magnets. Notice I have a little bit of the ferrite core sticking up, maybe 2 millimeters. And they're wound on sewing machine bobbins and with Litz wire, about 14 strands, very thin, insulated each strand, Litz wire made for high frequency. And for the motor coils, I wound more winds on them to raise the impedance a little bit. And here's notice the brass double nut, double nut, double nut. You lock it in, and you can adjust the air gap by when you put this upper stator plate, you know how far away it is from the magnets. By adjusting these nuts. It's very simple. Okay, so here's the lower skateboard bearing. I put a piece of tape there because I took the seal off the bottom side and I don't want any dust getting in there. So you put this on here like that. Then you take this thing, the upper one, this isn't the right way, I gotta turn it 180. Okay, there you go. So this is the way it's going to be. Upper stator plate, lower stator plate, rotor in the middle, basic Muller design, axial motor generator. And I'm going to be rectifying all the bottom ones and rectifying all the top ones. for now, I'm going to use the solid state relay. In a little while, I'll replace with a regular old MOSFET with a little driver chip and everything, like I did with the pink motor generators. So, anyways, so this is what I've been working on. I did a video of this when I put magnets behind the cores and stick them to the ferrite cores. And I had a couple coils shorted out. And it starts to lug, of course, from Lenz's law with shorted out coils. But when I put the magnets on, it speeds up very dramatically. So this has lots of potential, beating Lenz's law with backing. I call them backing magnets. That's what RomeroUK did. So he had magnets, and you have to play with it a lot, and different ways they face and different strengths to them. And while it's being loaded, and you get it to speed up under load instead of braking under load. So that's what I hope to be doing with this. Hold on a sec. Okay, I put it together. Now I have a little timing wheel up here. And there's 8 small magnets on the rim. Only 1/16 of an inch. There's one right there. Small magnets. Neodymiums. And they will spin past this Hall effect right here. And then I have this little sliding, see how the Teflon tape container, I have it sliding so you can adjust the timing real precise while it's running, and then lock it in with that screw right there. So notice how well the rotor spins. This is filling up caps as it's spinning. So I suspect on startup it's going to be kind of chugging because it's going to be filling up these 100 UF caps, but once these get kind of filled up and not filling anymore, now it's just going to run really smooth. And then I plan on running the top stator plate, all of them rectified, like all in series or all in parallel, but running them all together, bringing it out in an output, and also doing the same with the bottom. Let's see, these 2 black coils here, those are the motor coils on this side. So you see there's my air gap. I'd say about 2 millimeters, 1.5 to 2 or so. Now the generator coils I have higher away from the magnets, or about 4 millimeters. And also the little ferrite core sticks out too. That's what RomeroUK did, is he stuck, the ferrite cores were out a little bit, and I'm using Litz wire and sewing machine bobbins for the coils. And I wound more winds on the motor coils to raise the impedance. So I'll be running this. I'm going to run it on a solid state relay, did I mention that? And then I'm going to switch to a regular MOSFET later, see if it helps. It probably will. And I want to use a DC to DC boost converters with this too. What I'm thinking is make it so there isn't much lens law because I'm taking out very low voltage, and then boost it with a boost converter. Send it into a cap and see if it'll self-run and loop. We'll see. We'll see. I did get this motor in a video about 3 or 4 years ago. I had magnets behind the generator coils stuck to the ferrite. Right back there, ferrite core, and you stick magnets on them. And I got it to speed up while the coils were shorted. I have like a 46-second video showing that, so that was pretty successful. Now I want to take it to the next level and fill up some big caps. Now that I'm back in Seattle, I can use all my billions of caps, big caps, all my boost converters, my pulse width modulators, got a bunch of those. Thinking also the output of these, why not modulate it, put it through a pulse width modulator. It's all about trying to beat lens law breaking with this thing. So here's what I mean by magnets behind the coils. So this is what I'm working on. And I should be running it tomorrow. Okay, thanks for watching.